It can't happen the other way. You are in Iceland after all. My name is Ian, and I'm going to be hosting the show for you today. And as I'm sure you've already guessed by my accent here, I am not actually Icelandic. I am instead from Scotland. Freedom! Yes, I am indeed Scottish, although maybe not the Scottish accent you're used to. And that's because I actually come from the Isle of Lewis, in the Western Isles of Scotland. There you go. The Outer Hebrides, if you prefer. And that is where I was a primary school teacher for 23 long, painful years. I eventually decided that working with small children every day was just far too dangerous. So I came here to play with molten lava instead, much safer. No, actually, the real reason I came here was that I met and eventually married a lovely Icelandic girl.
Aww.
And actually, based on the fact that the Vikings were coming to Scotland, taking their women and bringing them here, I mean, basically, I just came here to get one back. But I did fall in love with Iceland very, very quickly. And it's not difficult to do. I mean, let's face it, it is a pretty incredible place. And especially if you're into geography or geology in any way, it's like heaven. And I am into geography. My dad was a geography teacher in a high school, so he taught me very well from a young age. And I went on then to study geography myself at Glasgow University, which I did for a few years, until it kind of stopped being about the fun things like volcanoes and started being more about statistics. Not my thing. So that's when I sidestepped into teaching. But all this physical geography stuff is my first love, so hopefully I can share my enthusiasm for the subject with you all today. Anyway, that's enough about me. What about this show? Whose bright idea was it to get a bunch of people like yourselves into a showroom and pour molten lava in amongst you? I mean, it is a slightly crazy idea. And this crazy idea came from our two founders, Julius and Raka. So they're a married Icelandic couple. And they were really inspired to create this show as a direct result of something very significant that happened here back in 2010, which was, of course, the eruption of, altogether, a volcano. There you go. It's going to be like that, is it? Fair enough. Specifically, we are talking about Eyjafjallajökull.
Fair
What's
play
wrong
to
with
you.
you people? Come on. No, but it was a very famous eruption, and it was famous for a couple of reasons. One being the ash cloud that shut down all the airports in Europe for about a week. Y'all remember that?
Yep.
Well, I say all the airports, all except for one. Keflavik. Here in Iceland. All the Icelanders were flying off to Florida. So long, suckers. And the other thing that made it so famous was that name. Because as we have just established, if you do not speak Icelandic, Eyjafjallajökull is a bit of a tongue twister, to say the least. But you seem like a willing group today. And I am a teacher after all. You know where this is going, don't you? Would you be up for learning how to say it? Yes? Excellent. Don't be intimidated, right? All these ridiculously long Icelandic place names are actually just very descriptive. So when you break them into chunks, it makes it a whole lot easier. And this one's only in 3 chunks. So it's not by any stretch the hardest one you're going to meet, trust me. My wife and I once stayed in a place called Svalbard Strandareipur. So relax, this is fine. So here we go. Chunk number 1 is Eyja. That means island. Second part is Fjalla, which means mountain. And the third part, Jökull. Yeah, the confidence level starting to kind of wobble a little bit there. If you are struggling with that weird sound on the end, that sound, if you lift your tongue up to the roof of your mouth, blow air out through your cheeks, and then spray everybody around you with spit, that will actually get you fairly close, and I'm not even kidding. Try it again. Jökull. There we go. So that means glacier. So when you put it all together, it's island, mountain, glacier. See? So repeat after me. Eyja. Fjalla. Jökull. Pretty good. I'm on 3, the whole thing. 1, 2, 3. Eyjafjallajökull. Ta-da! Round of applause. That was pretty good. I say pretty good. I mean, it was certainly better than the TV news people managed, especially the American ones. Sorry, most of them gave up trying entirely. They just called it E15 instead. E for the first letter, and 15 for all the rest. But although we all heard about the ash cloud part of that eruption, actually the volcanic system itself began erupting almost a month before all of that chaos. So in between Eyjafjallajökull and Mýrdalsjökull, there's a ridge there called Fimmvörðuháls. Don't worry, I'm not going to make you say that. But lava was flowing there off the mountainside in the highest recorded lava fall anywhere on the planet. 200-meter high lava fall, over 600 feet, an incredible sight. So Julius and Braka, being Icelandic, Icelandic people are a bit weird. Anytime eruptions are happening, instead of running away from them like normal people, Icelandic people run directly towards them and usually bring sausages. This is true, actually. So they were standing watching this incredible sight, saying, everyone should have a chance to see lava flow like this. But it's actually not that easy to achieve, even here. I mean, you'd be forgiven for thinking that we have eruptions, every couple of days or something. We don't. On average, it's around about every 3 to 5 years. And when they do happen, often it's miles off in the highlands, somewhere completely inaccessible. Or like the recent activity we've been having down there by the Blue Lagoon, it's just been too dangerous for people to go there. So Julius and Braka, they just wanted to find a safe, repeatable way for people to experience lava. Well, this is what they came up with. So what is this? What do we actually have for you today? Well, first of all, we've got a beautiful video presentation up on that big screen there. And the visuals in this are stunning, but it's also packed with information about why Iceland is such a volcanically active place. And it goes on then to talk about some of the most significant eruptions we've had here since the settlement by the Vikings. And then after that slightly over-dramatic video, you'll see what I mean, that's when we're going to pour the lava. It'll come down that slide beside me there at 1100 degrees Celsius, 2000 Fahrenheit. So it's going to get fairly warm in here, especially if you're sitting in the front row or up on the balcony there. You're really going to feel the heat. So some of you might want to consider taking off a layer or two. Some of you, please don't. Keep it modest, that's all I ask. The flow of lava that we have for you is what's called pahoihoi. The words for lava flows, they're Hawaiian terms. Pahoihoi being the really smooth, runny kind of lava that you see in all the pretty pictures, very fluid and bright in colour. There's another type which is quite different called a'a, which is much more viscous. It doesn't really flow along, it crawls, and as it does, it gets ripped apart, big sharp bits stick out of it, which is apparently why it's called a'a. Because the Hawaiians would walk on it and go, Okay. Anyway, it's going to flow over this ice block here, first of all. Now, that's just to show you the interaction between ice and lava that's so common here. In this situation, it should be a bit more subdued. We should hopefully just see steam bubbles rising up through the lava as it flows over the top. But in a real eruption, it's going to be a different story entirely. When you have glacial ice pressing down and then hot lava rises up to meet that, steam explosions that shatter that lava into tiny fragments. And the tiniest, they'll just go straight up in the air. So that's the volcanic ash that caused all the problem with those flights back in 2010. The heavier sediment, though, the sandy material called tephra, will rain back down to the ground pretty quickly. And much of that then gets washed down to the coastlines by these massive glacial flash floods. And this is what I'm talking about, this stuff here. This is tephra. You've probably seen plenty of it in your time here already. It is commonly referred to as black sand, but it's actually not sand at all. It is plain old basalt, the exact same as the columns there. In fact, there's actually no difference between that stuff and the columns except for the way they were formed. It's just that the columns would have formed in a deep pool of lava over a long period of time. The stuff on the slide there got blasted out of the crater of a volcano. And from a specific one, actually, because we as a company here, we have a special connection with the volcano Katla down on the south coast. And we take this material from a place called Mýrdalsandur, which is just east of the town of Vík. And we take it from there because we know that it came directly out of the crater of Katla when it last erupted back in 1918. So this is genuine Katla lava that we are remelting in our furnace back there for all of you over 100 years later, which I think is pretty cool. Okay, a couple of safety notes then before we go on. Folks downstairs, you should have received safety glasses when you came in. You don't need them just yet. The video's not that dangerous. But after the video, I'll remind you to put them on, and we'd like you to keep them on basically the whole time the lava's in the room. So once the lava comes in, glasses on, they stay on until you leave. When you do leave, out those two back doors there, you'll find clear plastic buckets at the bottom of the steps outside. And if you just put the glasses in those buckets as you go, we'll wash them and we'll use them again. Okay? What else do I have to tell you? Oh yes. Don't touch the lava. Now, I shouldn't have to say this, and yet, here we are, because I've literally had a situation where a guy who was sitting in the front row down here, right where you are actually, so watching you, he got up out of his seat at the end of a show and he was heading to the door over there, spotted a piece here that he quite liked the look of, and I saw the hand going out to pick it up, and I had to physically grab him and pull him back. The piece was about 400 degrees Celsius at the time, so please don't do that. But by all means take photos and videos, that is fine, but we would just beg of you, please turn the flash on your cameras off. You can do it right now if you like. It's very distracting for the hosts, but also pretty unpleasant for the people around you who are being blinded by the light. Yeah, just make sure you've got that turned off. I will remind you of that later. The only other thing is to ask questions. So towards the end of things, I'll open it up to the audience, and you can ask me basically whatever you like. I will do my very best to answer you, bearing in mind, I am a teacher, so if I reach the limit of my knowledge, I will do what all teachers do. I will make it up. But I'll say it very convincingly. Anyway, one more thing, and that is to meet this guy. A round of applause, please, for our lava melter. Alright, this devastatingly handsome fella is Nikita, and he is our melter today, which is why he's wearing this frankly ridiculous looking suit. And it does look silly, but it's necessary. He's operating a furnace back there that's currently running about 1300 Celsius. He's just about to pour lava out of it while standing right beside it. And then having done so, this is where he really needs the suit actually, he's going to go around the back of the furnace, open up the door, and then start hand shoveling in the hardened lava from the last show to get remelted again. And that fully exposes them, yes, you're very strong, fully exposes them to the blasted heat that comes from there, and it really is quite tremendous, so hence the suit. Also the visor there on the helmet, the shiny visor. It's actually gold on the visor, a very thin layer, so don't go mugging it later or anything. But gold's a fantastic reflector of heat and light. That's why astronauts have it on their helmets, and that's why he's got it on his as well. So, how's it looking back there? Lava ready? Yes. I've been worried there. Right, go on, back to your cave, Nikita, thank you. Yes, bye-bye.
Now we know what the suit was for.
Alright, so while he heads back there, we'll watch that video and then we'll pour the lava.
Lava show.
Just in case you weren't sure.
Iceland is one of the most active volcanic places on Earth, with a significant eruption every 2 to 4 years on average. There are more active volcanoes concentrated in Iceland than anywhere else on the planet. Iceland has 30 active volcanic systems, of which 20 have erupted since the settlement of Iceland over 1,000 years ago. There are two main reasons why Iceland has so much volcanic activity. First, Iceland is sitting right on top of a powerful mantle plume that continuously pushes magma towards the surface. Mantle plumes are sometimes referred to as hot spots, and in Iceland, the center of the massive magma plume is nestling right below Grímsvötn, the most active volcano in Iceland. The other reason for Iceland's intense volcanic activity is because of the mid-Atlantic ridge that cuts right through the island. The ridge consists of two tectonic plates that are steadily moving away from each other, about 2.5 centimeters per year. These tectonic movements leave cracks in Earth's crust that make it easier for the magma to reach the surface. The magma plume below Iceland and the mid-Atlantic ridge make Iceland one of the most volcanically active places on the planet. There are only two natural phenomena that can result in an extinction rate catastrophe. One is a large meteor hitting the Earth, similar to what happened 65 million years ago, leading to the demise of the dinosaurs. Thankfully, we have not been in any real danger from another apocalyptic meteor crash since then. However, the possibility still remains. The only other natural disaster that could lead to an extinction rate catastrophe is a violent eruption of a so-called supervolcano. There are 6 known supervolcanoes on Earth, and Yellowstone is undoubtedly the most famous one. Yellowstone last erupted 640,000 years ago, and the direct impact zone covered more than half North America. But what are the odds of a supervolcano going off in our lifetime? Scientists say that it's not likely. But even if we don't have to worry about a supervolcano erupting, there are still about 50 volcanoes actively erupting in the world at any given moment. In Iceland, some of the eruptions that have taken place in recent years have been fairly small and seemingly innocent. Some have even been called tourist eruptions. But don't be fooled. Icelandic volcanoes can be very dangerous, even deadly. To better understand the most catastrophic volcanic eruptions in Icelandic history, let's go on a journey back in time to the year 870. This was when the Nordic Vikings decided to face the open sea in search of new land. They ventured further west than anyone had ever gone before. Days turned into weeks and the vast ocean seemed endless. Just as they were about to lose all hope, the ravens opened their wings and flew away. That could only mean one thing. Land was near. On the horizon, white mountain tops appeared, resulting in the name of this new land, Iceland. As they sailed closer, they could see rocky hills covered with moss and birch trees. There were no people in sight, and it didn't take long for the Vikings to settle down and build their new homes. With time, people learned to live with the harsh weather conditions and the dominating raw nature. Over the next decades, more settlers arrived that were welcomed with open arms. There was plenty of space for everyone, and for over 50 years, the settlers of Iceland had their own little ill-weathered paradise all to themselves. But then, Mother Nature decided it was time to remind those newcomers that this remote island in the north was her domain. All hell broke loose in one of the most catastrophic eruptions in modern history. It was the Eldgjá eruption. Eldgjá means fire canyon, and no wonder. The earth was ripped apart in a 75-kilometer-long fissure in what is still today the largest volcanic canyon on Earth. The Eldgjá eruption lasted for 4 years, and it produced the greatest amount of lava in historic time. The volume of lava covered more than 800 square kilometers of land, which is equivalent to the entire Reykjanes Peninsula being swallowed by lava. The Eldgjá eruption marked an end of an era where settlers came to Iceland. From then on, everyone was warned from setting sail to the hellish island of ice and fire. This was made immortal in a famous poem called Völuspá.
Sól tér sortna, síður fold í mar. Hverfa af himni, heiðar stjörnur, geysar eimi við aldrun vara. Leikur hár hiti við himinn sjálfan.
Now let's go forward in time of more than 300 years, which takes us to the next volcanic catastrophe. The ice-capped stratovolcano in southeast Iceland, which also happens to be the highest peak on Icelandic soil, then went by the name Knappafellsjökull. The volcano was surrounded by fertile grazing lands, which supported at least 40 farms in an area formerly known as Litla Hérað, or Little Shire. One day, out of the blue, the top of the volcano exploded in a massive eruption, bringing about a deadly pyroclastic flow made up of gas and volcanic ash of 1,000 degrees Celsius, traveling down the volcano at 700 kilometers an hour, killing every living being in the area. This eruption was such a devastating event that the whole surrounding area became a lifeless wasteland for years to come, which led to a new name of the volcano, Öræfajökull, the volcano of ruined wasteland. In the fall of 1783, the Lakagígar eruption began. The Laki eruption consisted of a 25-kilometer-long fissure lined with 130 craters. Although the eruption did not turn out to be quite as enormous as the Eldgjá eruption 850 years earlier, human societies had developed a lot since the 900s, and events of this scale were now recorded in much greater detail. Massive clouds of poisonous hydrofluoric acid and sulfur dioxide clouded the northern hemisphere for years. It caused a global drop in temperatures of 2 to 3 degrees Celsius and led to a devastating drop in quality of life in many areas of the world. Western Europe was particularly badly affected, which is why the Lakagígar eruption is considered to be one of the fundamental reasons for the French Revolution taking place just a few years later.
Volcanic ash has caused the worst disruption in air travel since 9/11.
The infamous eruption in Eyjafjallajökull in 2010 put Iceland in the spotlight big time.
Created by lava bursting up through the glacier.
The massive ash plume that rose many kilometers into the atmosphere brought air traffic in Europe to a standstill for a whole week. More than half the volcanoes in Iceland are covered by glaciers, and whenever lava gets in contact with ice, it results in violent explosions that fractures the lava into superfine particles that rise high into the air and can ignite the engines of airplanes. Not a risk you would like to take. After 800 years of sleep with no volcanic activity, the Reykjanes Peninsula has awakened yet again, beginning what geologists call a new era in Icelandic volcanic history. It all began with the eruption in Fagradalsfjall in 2021. Since then, Fagradalsfjall has erupted several times without any harm to people or infrastructure due to its convenient location in the Reykjanes Highlands, situated 30 kilometers from the capital area and 15 kilometers from the Keflavik International Airport. The eruptions in Fagradalsfjall marked the beginning of a new active period on the peninsula. But the Fagradalsfjall volcanic system is only one of 5 volcanic systems on the Reykjanes Peninsula that all seem to be interconnected. In 2023, Svartsengi volcanic system stirred, first with a strong earthquake swarm by Grindavík that soon led to repeated volcanic eruptions. And now that the Reykjanes Peninsula has awoken from its centuries-long slumber, there is a real possibility that the capital area could be in danger in the near future. It's been almost 5,000 years since lava last flowed in Reykjavik. Well, that's until now.
All right, folks, so if you put your safety glasses on now downstairs, and a reminder to you all to turn off the flash on your cameras, and get ready to feel the heat of real molten lava. And folks up on the balcony, you're welcome to stand for this part.
Too lazy. Yeah. Wow.
You can see how it just lights up the whole room when it comes in. And there's that bubbling reaction there where it hits the ice. You can see just how fluid that lava is as well. When lava is this fluid in nature, when it comes to the edge of a mountainside and goes over that edge, the wind can get a chance to catch it. And you get these lovely features called Pelly's hairs. So these are Pelly's hairs. They're super fine strands of lava, and they cool really quickly in the air, as you can see. They form these lovely glassy threads. And the geologists, they absolutely love finding these because they're actually quite hard to come by in nature. Because they're so fragile, they tend to get broken apart very easily and they get blown away by the wind. So that's why the geologists love finding them. Farmers here in Iceland, on the other hand, are not quite so keen on these because those glassy fibres, they get into the grass that the animals eat. That messes up their stomachs. So that's why in Icelandic, they've actually got a different name. They're called Nornahaur in Icelandic, and that means witches' hairs. Alright, so you can see that the flow of lava on the surface now at least is pretty much stopped. There's not really any moving lava there at all, but there is actually molten lava still flowing out from underneath all of that. That is an important point, and one that I will come back to shortly. But right now I've got a block of ice down here. Do you want to see what happens when we stick ice on the lava?
Yeah.
Yes, you do. Okay, just checking. Alright, so I'm just going to drop this down here on the channel, right about here. Apply a little bit of pressure to that. So what happens there is that some of that steam escapes into the air, but some does get pushed down into the lava. As you can see, it actually starts causing the lava to inflate. So a little bit of inflation going on there. And you can see that where the ice has been, already we've got a nice sort of solid crust forming on the surface of that. Even down here at the front, although the ice hasn't reached that far, you can see you've got a nice crust on the top of that too. But don't be fooled by that. We get in underneath that. There we go. Woof. Now, do you feel that wave of heat hitting you as I flipped it? Right. That's happening because lava is in fact a tremendously good insulator of heat. It does not transfer heat well through itself at all. So when it does form a crust like that on the surface, it'll keep what's underneath that really hot for a really long time. In fact, if I dig back in there, you can see I can still get Pelly's hair out of that quite easily. I mean, it is getting a little bit more viscous at this point, and you can actually tell that just by the colour. So you can see the hotter lava that I'm drawing up from underneath is a much brighter yellow. But as that begins to cool down, you can see it fades more to orange and then to red and then fully down to black, as you see there. And if I drag the pole over the surface now, you see that kind of skin that's forming on the top? So that's happening, well, it's actually responsible for these features you see here, these ripples on the slide. So you get it happening basically anywhere where you've got fluid lava like this. It begins to cool on the surface and forms that skin. But the hotter lava underneath that keeps on flowing, like I showed you down here at the beginning, that'll drag that skin along behind it. And eventually when the surface fully cools, the ripples just get locked in place. And you can see the direction that the lava was flowing in. And you can see fantastic examples of this all around the country if you keep your eyes open. There's a really nice one. If you go to Thingvellir National Park, there's a lookout point there over the park. If you're standing there, it's right on the ground beside you. Beautiful big ropey strands of lava. So it's ropey texture, or ropey pahoihoi, which is just fun to say. If I get in underneath this, I can show you the underside of the lava here. Just get in here and lift that up. And again, you get that wave of heat, and you see how fluid that still is underneath. Don't worry, folks on the other side, hopefully for you too. Equal opportunities. There we go. Whee! Beautiful. And because it is still so liquid underneath, it will actually allow me to do some other fun things too. So, get my pole back. I can get in underneath the flow here and gently does it. I can actually pry up the whole stream of lava like so, form a kind of bridge out of it. And that can allow, if there's any liquid lava still inside there, it can allow it to flow out the back or down, and if we're lucky, we could even get a little lava tunnel to form in there. But you can see that's now holding its own shape quite nicely. So it's still flexible on the inside because it's still so molten. That outer shell is holding it all together really well. Okay, so at this point I'm going to start clipping some safety guards onto the slide beside me here, and I'll explain why. So we're pouring our lava onto a steel slide, and the steel, as soon as the hot lava hits it, the steel expands really quickly with the heat. But of course everything starts to cool down pretty quickly as well, including the steel, and when it does, the steel contracts, tries to pull back into shape, and that pressurizes the lava sitting on top of it. And anytime you get pressurized lava, it's going to relieve the pressure by popping and cracking. And so you are going to hear some pretty loud cracks and bangs coming from the slide here as the show goes on. That is perfectly normal. But we always clip these guards on. It's really just to catch any little pieces that might try to fly off as it cracks. And that is mostly being done for the benefit of one person in this room. Me. Because I'm standing right next to it. And I don't know if any of you have ever had a shard of hot lava go down the back of your shirt before, but I can assure you it is not much fun. So that's why we do that. Alright, so I get a little fun visual of the heat here. So I've got some paper towels here in my back pocket. So we put one of these on the coldest part of the lava, where that ice block was. So I just drop that on there like so. And it ignites pretty darn quickly. So cold is relative, is the lesson from this. I'll find out how cold. So I've got one of these infrared thermometers here. So I'll take a few temperature readings and show you what we're dealing with here. So the surface temperature of that coldest section, that is giving me a reading there of, that's about 352 Celsius in that blackest part, which is 666 Fahrenheit. Oh, the lava of the beast. But that's just on the surface though. If I get underneath all of that, if I break through that crust, get into this stuff, inside there, it's jumping up there to 658 Celsius, 1217 Fahrenheit. I didn't have to go far down into the lava at all to get that big jump in temperature. In fact, if I just do this at the front, let's see what's happening on the underside here, out of curiosity. Yeah, it's up there to 845 Celsius, 1554 Fahrenheit. And that's just a short distance down into the lava. Now that's actually a really important point, because we do see a lot of people coming to Iceland and doing some fairly questionable things. There are whole Facebook groups dedicated to this, actually. There's one called Stupid Things People Do in Iceland. Somebody might be on it. Somebody might end up on it before you leave. But one of the things that we see people doing all too often is going out walking on freshly cooled lava. And it's a really bad idea for many reasons, but one's exactly what I was showing you there. The lava might have cooled to a crust on the surface, and the crust could be dark in colour, it could even be cool to the touch. All well and good, but you've got to remember that lava is a phenomenal insulator of heat. You can have incredibly hot, or even still molten material directly underneath that surface crust for months after an eruption has taken place. And you've got no idea how thick or thin that crust is. You can easily dislodge a section of something, and next thing you know, you've got red hot stuff at your feet. Aside from that, there's always the risk of lava tunnels as well. They find these all over the place. We found some in the 2021 lava field at Fagradalsfjall. The scientists were going to go down into these tunnels to explore them, but they didn't get very far. Because at the mouth of the tunnel, they were getting temperatures well in excess of 400 Celsius. And that was 2 years after the eruption had ended. Right? Not only that, and I love this, but they could actually see daylight through cracks in the ceiling above. So it doesn't take a genius to work out. You could be walking on that unstable surface, next thing you know, crack, down you go. And Okay, you're not falling into molten lava necessarily, but still 400 Celsius, you won't last long. So that's why we recommend that people just stay off the lava if you can possibly help it. Now, I'm going to get underneath the flow here and see if I can break up this bridge a little bit. Now, as I lift there, it's actually forming a crack, but it's not actually breaking. It's telling me the lava in there is actually still fairly gooey. Let's see if I can actually break this up a little bit for you. There we are. Yeah, that bit there is actually still just about stuck to the bit beside it. Let me show you what we're dealing with here. Grab this chunk. There we are. There's some lovely medium rare lava there. Just the way I like it. Let's bring it around so you can all see. There we go. Anybody want a souvenir? Cash. We're not doing that. But you see that lovely red-orange glow from the lava? You're only actually going to get that glow from the lava if it's still over 600 Celsius. When the temperature comes down below that, it's not able to release the energy as visible light anymore. It will still release heat, of course, but just as infrared, which we can't see. And it will actually lose the heat from the surface to the air very quickly. That's what catches people out. So that piece that I just took out a few seconds ago, if I just lift that back up again just now, you can see how much that's dimmed down in colour already. I mean, it's not fully black yet, but it's well on the way. Whereas if I grab one of these bits that was right beside it, you can see a significant difference in the brightness there. Okay? Now that effect I'm showing you, that's actually how you get lava tunnels forming in nature. So when you've had a flow of lava that's wider and deeper than what we have here, the same thing will happen. It's going to cool the fastest on the outside, where it's in contact with the air, and that rate of cooling in nature is around about 100 degrees Celsius being lost per kilometre that the lava travels. But that's just on the outside. When it cools on the outside, it forms that shell around itself. The lava inside that will only lose maybe 1 degree per kilometre. So it can actually go incredibly long distances inside its own insulation. And as long as you've got a supply of lava rising up into that system, and downstream there's an outlet for it to get out from, you can just